Welcome to the Explainer. Look, if you're aiming to absolutely conquer Cambridge AS and A-level mathematics, specifically syllabus code 9709, you are in exactly the right place. Today, we're opening up the ultimate insider's playbook to help you build an architectural blueprint for a flawless, perfect answer. And our specific target for this session? It's one of the most notorious traps in the entire syllabus, quadratics, hidden inside some other function of x. We're going to deconstruct this topic like master architects, and by the end of this, we'll transform your answers from a chaotic jumble of numbers into genuine structural masterpieces. Let's get right into it.
So you really have to ask yourself, what actually separates a B grade from an A star in A-level mathematics? Let's look at a very real scenario based on past paper questions. We see this from syllabus codes like 0580 all the way up to 9709. Imagine two students facing a complex quadratic equation that's sneakily hidden inside an exponential function. First, we have Alex. Now, Alex has memorized literally every formula in the textbook. During the exam, Alex overloads the page with raw mathematical facts, just writing down absolutely everything they know about exponentials and quadratics. But here's the problem. There is absolutely zero analytical depth. It's just a massive data dump. Then, on the other hand, we have Sam. Sam is fast, Sam sees the equation, completely rushes past the command words, starts calculating wildly, and entirely misses the actual underlying requirements of the question. Both of these students are going to walk out of that exam hall feeling super confident, and both are going to be incredibly unpleasantly surprised when they get their papers back covered in red pen marks. The truth is, the difference between a B and an A star doesn't lie in raw memorization. It lies entirely in the structural framework of your answer and the depth of your analysis.
Okay, let's dive into this, because balancing these specific cognitive domains is the absolute secret to giving Cambridge examiners exactly what they're looking for. Think of it like a giant puzzle. These three slices you're looking at represent the cognitive domains tested in your exam: knowledge and understanding, application, and analysis. Do you notice how carefully they are balanced? Cambridge principal examiner reports consistently, year after year, highlight that their assessment framework prioritizes analytical depth way over superficial breadth. Think back to our two students. Alex failed because Alex only lived inside that knowledge slice. Sam failed because Sam tried to jump straight to the application slice without actually doing the analysis of the command words. To secure those top-tier marks, you need a harmony of all three, but you have to lean heavily into careful, deliberate analysis before you even think about picking up your calculator. So, here is our architectural blueprint for today. We're covering four main sections. 1. Core principles. 2. The procedural framework. 3. A critical analysis toolkit. And 4. Top examiner warnings. Let's kick things off with part 1, core principles, deconstructing command words. Let's take a second to clearly define our specific enemy today. We are dealing with quadratics in some function of x. Now, you already know your basic everyday quadratic, right? The classic ax squared plus bx plus c equals 0. But Cambridge examiners, they love to test your analytical depth by hiding that familiar structure. Instead of just giving you an x, they substitute a completely different mathematical function in its place. Let's call that hidden function u. So the form actually becomes au squared plus bu plus c equals 0. And that u might be e to the power of x, it might be sine of x, or it could even be a much more complex polynomial. This right here is the theoretical architecture of the entire topic. It relies so heavily on integrating different areas of the syllabus. You have to understand that cross-topic connections are the absolute foundation of A-level mathematics. If you can train yourself to spot a quadratic hiding inside a trigonometry question, you have literally just unlocked the highest tier of marks available. To expertly handle this, we're actually going to adapt a framework you might recognize from the humanities, Peel. I know, it sounds crazy, but yes, we are bringing an essay structure into advanced mathematics, and you're going to see exactly why it's a game changer. Step 1 is point. You deconstruct the question. You explicitly state to the examiner, hey, this is a quadratic equation disguised as an exponential. Step 2 is evidence. You extract the data. You literally write, let u equal e to the power of x. Step 3 is explain. This is where you solve systematically for u. And finally, step 4 is link. You evaluate and verify, making sure you link that u back to x to find your actual final answer. Think back to our hypothetical students Alex and Sam. Which steps did they totally skip? Well, Alex missed step 1 completely and just wrote down random facts. Sam rushed mindlessly through step 3 and entirely forgot step 4. By forcing yourself to follow this exact sequence, your mathematical reasoning becomes absolutely undeniable to the examiner.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving right along to Part 2, the procedural framework, execution and transformation.
Now, what's really interesting about this strategy is how we can take those red pen mistakes we talked about earlier and transform them into green checkmarks. Let's walk rhythmically through the standardized sequence for processing these complex quadratics. Imagine you're actively rewriting Sam's flawed answer right now alongside me. First, you identify the key elements. You look at an intimidating equation, something like e to the power of 2x minus 5e to the power of x plus 6 equals 0. You take a breath and you identify that hidden structure. Second, you apply the principles. You explicitly write down, let u equal e to the x. That simple, single statement is your structural beam. It holds the whole answer up. Third, you execute the analysis with crystal clear working. You rewrite the equation as u squared minus 5u plus 6 equals 0. You factorize it. You get u equals 2 or u equals 3. Fourth, and this is absolutely crucial, you verify your results. You are not done yet. Fifth, you present everything in the correct format. You substitute it back. E to the x equals 2, so x equals the natural log of 2. E to the x equals 3, so x equals the natural log of 3. You use clear terminology, proper headings, and appropriate formats. I'm telling you, that exact sequence is your blueprint for maximum marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's dive into Part 3, our Critical Analysis Toolkit Interactive Workshop. Get ready!
Our first challenge here is the data scan. We've got regular quadratics in column 1, trig-based quadratics in column 2, and exponential-based quadratics in column 3. I'm giving you a theoretical 60 seconds on the clock. Scan the data, extract the core mathematical trend. What is the comparative connective that's just hiding in plain sight here? Well, it's the fact that despite the really complex functions, whether you're dealing with cosine squared of x or e to the power of 2x, the underlying structural skeleton remains completely identical. The a, b, and c coefficients still completely dictate the behavior of the curve, totally regardless of what u represents in that specific problem. Recognizing this exact structural similarity is precisely what Cambridge examiners mean when they say that top candidates identify similarities and differences with evidence.
Let's move straight into Challenge 2, Find the Flaw. Look at these steps. In Bullet 1, the student substituted u equals e to the power of x correctly. Great start, solid. Bullet 2, they solved u squared minus 5u plus 6 equals 0 for u. They got u equals 2 and u equals 3. Again, perfect execution of the analysis. But then, look at Bullet 3. Stated final answer as x equals 2, x equals 3. Bam! Did you catch it? Where exactly did they lose the marks? That's right, they totally failed the evaluate phase. They stated the final answer as x equals 2 and 3 without converting it back using natural logs. The principal examiner commentary on this specific mistake is pretty brutal. It shows a complete failure to check for reasonableness and a failure to link the abstraction back to the original context of the question. As we said before, don't build a beautiful house and then forget to put the roof on.
All right, Challenge 3, the Speed Writing Challenge. You have 30 seconds on the mental clock. Imagine you're in the exam hall, the clock is ticking, and you have just found that u equals 2, where u is actually the sign of x. How do you write that perfectly formatted verification step using our deconstruct, solve, evaluate method? You have to maintain strict presentation conventions here. First, you write returning to original variable as a clear, distinct heading. Then you write sign of x equals 2. Now you evaluate. You write, since the range of sign of x is between -1 and 1, sign of x equals 2 has no real solutions. See what you did there? Clear annotation, completely justified decisions. You don't just put a messy cross through it. You explain exactly why mathematically it doesn't work. That, right there, is A-star evaluative thinking under intense pressure. Which brings us to our final section, Part 4, Top Examiner Warnings and the Final System. So the crucial point is knowing what to avoid. Here are the 3 deadly sins of A-level mathematics when you're dealing with quadratics in some function of x. Mistake 1, using the wrong approach for the context. This means trying to blindly apply the quadratic formula without first establishing a clear u substitution. It just leads to massive, messy algebraic tangles. Mistake 2, poor format and presentation.
If you're scrawling calculations in the margins, you're making it literally impossible for the examiner to follow your logical, structured reasoning. Mistake 3. Giving answers that are not specific to the given context. As we just saw in our challenge, leaving an answer as u instead of solving for x, or maybe giving a negative root for an exponential function, which of course cannot logically be negative. Listen, when structural methodology is abandoned because you're rushing calculations, your top marks vanish instantly.
And this actually brilliantly illustrates our main thesis today. This is a direct quote pulled straight from the Principal Examiner report. It says, "Candidates referencing cross-topic connections achieve significantly higher marks. It is absolutely vital to show integrated knowledge. When you encounter a quadratic hiding inside a trigonometry paper, explicitly state that connection on the page." Top-scoring candidates constantly demonstrate this evaluative thinking by justifying their decisions with hard mathematical evidence. You need to show the examiner that you see the whole architectural blueprint of the entire syllabus, not just isolated, disconnected rooms. Please, whatever you do, listen carefully to this. Examiner alert. Students lose immense, tragic amounts of marks simply by not showing their working. This right here is the core secret of the insider's playbook, the method mark strategy. Think about it. Even if you completely panic, press the wrong button on your calculator, and your final numeric answer is completely wrong, method marks are your ultimate safety net for complex quadratics. If you just explicitly write out, let u equal e to the x, boom, you get a method mark. If you clearly show the correct factorization technique for your u equation, boom, you get another method mark. By building that clear, step-by-step procedural framework we've been talking about, you ensure that a simple arithmetic error doesn't completely destroy your entire grade for that question. It is an absolute lifesaver.
2. That single number represents the average grade boundary students jump when they actually consistently implement this exact procedural framework. Moving from a scattered, raw fact panic approach to a calm, analytical, structured, peel-based mathematical approach can literally take you from a C straight to an A. It is all about consistent implementation. Design your answer like a master architect. Make every single paragraph, every single equation block, an undeniable structural masterpiece.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Think back to the last past paper question you attempted. Be completely honest with yourself right now. Would your current working out secure all the available method marks, even if your final numeric answer was completely wrong? If your answer is no, then it's time to rebuild your foundation. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.